Good, good evening, everybody. Just a sound check. Am I loud and clear? Am I loud and clear? We're good to go. Right. Okay, then. Today we'll be discussing the 2002 A-level paper. 2002 A-level paper. Right? 2002 A-level paper. We have finished 2000 A-level paper. So today we'll do 2002 A-level paper. And next week will be 2001 A-level paper. Okay? Right. So first MCQ. First MCQ. First MCQ. I will get this erased. Right. Okay. Dimensions of frequency is. Yeah, now, frequency is 1 over periodic time. Frequency is 1 over periodic time. So, dimensions of frequency, one is dimensionless. So, 1, t, take on top, you have t minus 1. So, dimensions of frequency, very easy. One of the few things you do on the very first day in A levels, t to the power minus 1. Answer number 4. Answer number 4. Right. Moving on. Which of the following phenomenon could not be explained? Could not be explained by wave theory of light. Wave theory of light. Now in wave theory, what do we learn? Reflection, refraction, what else? Diffraction, interference, and then we also learn about what? Polarization. So interference, diffraction, reflection, all these wave theory. What is this photoemission? Photoemission is connected to photoelectric effect. This is connected to photoelectric effect. This we talk about the wave particle duality, the particle nature of light. Is it clear? Particle nature. So here photoelectric effect is particle nature. Particle nature of light. Okay. So wave theory, we speak about reflection, refraction, diffraction, interference, polarization. Photoelectric effect is photoelectric effect, photoemission. That's in wave particle duality, the particle nature of light. Particle nature of light. So correct answer, answer number 5. Answer number 5. Right. Look at this. We'll move it down a bit. Right. Okay. Which of the following could influence, look at the keyword, the speed of sound in air? Speed of sound in air. Look at the board carefully. Now, speed of sound in air, look at this carefully. Gamma P over rho square root. Also gamma RT over square root. Speed of sound. Right. If you look at this carefully, here we have frequency, temperature, humidity. Now, if you look at this, temperature will directly affect. You can see here. No? If you look at this, temperature will directly affect. Here, temperature will directly affect. What else? Humidity also affects. How humidity will affect? When the vapor content in the atmosphere changes, the density will be affected. When the density is affected, it affects the velocity of sound in air. In other words, when humidity increases, the water vapor content increases. the density of air or the air content reduces. Air content reduces means velocity of sound will what? Increase. So high humidity means velocity of sound increases. What about low humidity? Humidity low. Low humidity means low water vapor content, high air content. High air content means density of air is large, velocity of sound will be low. So B and C both will affect for sure. What about the frequency of sound? I just think like this. There's a trumpet playing and there's a what do you call somebody shouting. Trumpet is playing different frequency, somebody talking different frequency. If velocity of sound actually affects from frequency, trumpet sound and people talking we will hear at two different times, even if they are at the same distance. That's not true. So frequency does not affect the speed of sound. So correct answer is only B and C. Correct answer is only B and C. Write a small sentence there. Velocity of sound in air directly proportional to square root of absolute temperature. You can write it symbolically. V proportional to square root T. V proportional to square root T means temperature increases, V increases. Temperature reduces, V reduces. Temperature reduces, V reduces. Right. Next one is humidity. Humidity. Humidity increases. Density of water vapor increases. Density of air reduces. So density of air reduces. Velocity of sound in air will increase. Humidity reduces. Humidity reduces. Density of water vapor reduces. Density of air therefore will increase. More air content. Therefore velocity of sound will what? Reduce. High humidity, high velocity. Low humidity, low velocity. Okay, no? Quickly write down. Quickly write down. So correct answer here, answer number 4. Correct answer here, answer number 4. Right. Okay. Right. Let's move on. Have a look. Of the thermometers given below, the most suitable thermometer to measure of a drop of liquid. Drop of liquid means what? Drop of liquid means what? Drop of liquid means point temperature. That's the idea. Point temperature. Out of these, what is more suitable to measure point temperature? Only one, thermocouple. Thermocouples can be used to measure what? Point temperature. Point temperature. Others we can't use because now if you take, for example, alcohol thermometer, mercury thermometer, the bulb should be fully submerged in the liquid. So point temperatures, you can't fully submerge the thermometer, right? If you take gas thermometer, again the bulb should be fully submerged. If it's not fully submerged, you can't get a good reading. So pyrometer is also what? That's where radiation pyrometer. It's absorbing radiation. So point or liquid droplets will give less radiation, so it can't read properly, proper sensitivity. So thermocouple is the most suitable. Fourth one, answer number 1. Write a small sentence. In a thermocouple, now how does a thermocouple look? There you go. These are a different temperature, let's say theta 1. These are a different temperature, theta 2. Here you'll have one metal. Here you have one metal. Here you have another metal. That is connected to a center zero galvanometer. Once is different temperature here, there is a voltmeter reading. There's a voltmeter reading. Okay, no? So depending on that voltage reading, you can get a small idea. proper graph, or if you graph the proper diagram here, EMF, electromotive force with temperature. If you draw the graph, it's a graph like this, curving graph. There, curving graph. Okay. There's one sentence. As shown in the following figure, as shown in the following figure, as shown in the following figure, a thermocouple is used to measure point temperature. A thermocouple is used to measure point temperature. A thermocouple is used to measure point temperature. Because two different metals at two different temperatures will produce a EMF. Will produce a EMF. And from this EMF, we can measure. From this EMF, we measure an unknown temperature. An unknown temperature. Okay. Right. Moving on. Right. Look at this carefully. Volume expansivity. What is volume expansivity? Gamma. Volume expansivity of a metal is equal to, what is gamma equal to? 3 alpha. 3 times its linear expansivity. I think direct answer is there. 5 answer is answer 3. 5 answer is answer 3. I think that's about it. So quickly we can move on. Clear? Quickly we can move on. Right. Next one. When one touches a piece of metal in the environment, one feels it to be colder than the piece of wood. Look at the comparison. Nah? Look at the comparison. These small things, remember, metal, wood, comparison. Why do you feel it much more colder? So obviously there is something to do with conduction. Right, let's see. Temperature of the piece of metal in the environment is generally lower than wood. Metal piece has higher heat capacity. Temperature of the wood is close to the body temperature. Metal has higher thermal conductivity than wood. Surface emissivity of the metal is higher than wood. So most probably this is the suitable answer. Answer number 4. Why is that? Metal has high thermal conductivity. When you touch the metal, heat from your body quickly goes through the metal. When heat from your body leaves from your hand, you will feel what? Lower temperature. There, you will feel much more cooler. So from your body, heat is going out. That is why, because of thermal conductivity, only you feel it much more what? Cooler. Okay, no? Right. That is small sentence there. That is small sentence there. The reason that we feel it's much more cooler is because our body temperature is greater than the environment temperature. Is greater than the environment temperature. So when we touch the metal, from our body, heat moves out. From our body, heat moves out. From our body, heat moves out. This causes us to feel metal to feel much more colder. This causes the metal to feel much more colder because heat is moving out of our body. Because heat is moving out of our body. Heat is moving out of our body. Okay, no? Right. Moving forward. Right. During the formation of ice, the possible temperatures at the points are, remember, maximum density of water. If you take the anomalous behavior of water, temperature, density. If you plot the graph, anomalous behavior of water, maximum density occurs at 4 degrees Celsius. Maximum density occurs at 4 degrees Celsius. Maximum density occurs at 4 degrees Celsius. Carefully look. Now, when it's freezing, the temperature starts reducing. When the temperature starts reducing, maximum density molecules go to the bottom, right? So when the water starts getting colder and colder and colder and colder, at 4 degrees Celsius, all water molecules are at maximum density. So maximum density molecules go to the bottom. After that, when it cools down, yes, the temperature will reduce from high temperature to low temperature. Now here, maximum density means here plus 4 degrees Celsius is there. Now outside will be freezing. Outside will be freezing. So ABC plus 4, you have these three possibilities. These three possibilities. Okay. These three possibilities. Outside minus 5, 4, 0. This is wrong. This is wrong. You can't have two places 4. Here 4 degrees, here 0, here minus 5. This is most probably correct. Correct answer is answer number 2. Look at this carefully. Here 4, here minus 5. What happens is, it will travel from high temperature to low temperature like a conductor. Now, for this to actually purposefully take place, there should be warm water currents coming in. Warm water currents will come, keep on supplying this at 4 degrees Celsius. So heat keeps on going out. Is it clear? So remember, these connected to anomalous behavior of water. When the temperature keeps on reducing at 4 degrees Celsius, density of water is maximum. Maximum molecules go to the bottom. Top freezers. Then from high temperature to low temperature, heat keeps on going out. Then you will tell me, sir, if heat keeps on going out, then what happens? Everybody underwater might freeze. No, that is where hot water currents will come into play. Water currents. I mean, this question, everything is not given, but water currents play a very important part to keep this at what, 4 degrees Celsius. Okay, no? That's right. This is a consequence. This is a consequence of the anomalous behavior of water. Of the anomalous behavior of water. This is a consequence of the anomalous behavior of water. Anomalous behavior of water. Where the maximum density of water occurs at 4 degrees Celsius. Where the maximum density of water occurs at 4 degrees Celsius. Maximum density of water occurs at 4 degrees Celsius. And maximum density water molecules move to the bottom. And maximum density molecules move to the bottom. Maximum density molecules move to the bottom. While outside freezers. While outside freezers. While outside freezers. Put a small sign, right? To sustain this, warm water currents should keep on coming in. Warm water currents should keep on coming in. Warm water currents should keep on coming in. So heat can conduct through the ice layer. So heat can conduct through the ice layer. So heat can conduct through the ice layer. Okay, no? Right. I've given a full description. Right. Look at this carefully. Which of the following closed surfaces net electric flux is positive? So Gauss theorem, all of you all know, flux is sum of charges divided by epsilon naught. So sum of charges should be positive. Now here, negative. It can't be the first one. Here flux is 0. Here flux is 0. Here flux is 0. Here flux is negative. Here flux is net charge is positive. So if I write here for the fifth one, plus 2q minus q divided by epsilon naught. That's q over epsilon naught, positive flux. Correct answer will be answer number 5. Answer number 5. Right there. According to Gauss theorem, the sum of charges inside the closed surface is positive only in answer 5. The sum of charges inside the closed surface is positive only in answer 5. Only in answer 5. Right. Okay. Moving on. Right. Look at this carefully. An ideal transform. What do you mean by ideal transform? Ideal transform, input power, output power, both are same. Now a transformer has a primary coil and a secondary coil. Electric flux will link from the primary to the secondary. From the primary to the secondary. Right. So here, right. Now they are saying ideal means, remember this, VPIP equals VSIS. Input power, output power, both are what? Same. Right. They are telling you primary 100 windings in the primary, 200 windings in the secondary. Primary is connected to AC supply 120 volt 10 ampere. Then voltage current in the secondary is. So we can use the VP over VS equals NP over NS, usual equation. Primary is 120, VS we don't know, NP is 100, NS is 200. Simplify this. Therefore, you can say VS is 240 volts. Now VP is 120 volts, 10 amperes. IS we don't know, 240 volts. So IS is equal to 5 ampere. 5 ampere, 240 volts. 5 ampere, 240 volts. Correct answer is answer number 1. Ninth one, answer number 1. Right there. In an ideal transformer, the input and the output powers are equal. The input and the output powers are equal. The input and the output powers are equal. And using transform equations, we can find the secondary voltage and current. We can find the secondary voltage and current. Okay. Right. So we move on. Potentiometer. Right. Look at the board. So we have done this in the 2011 question paper as well. In the potentiometer, the balance length for EMF 1.3 was found to be 65. So if you can remember the theory, balancing length is proportional to the EMF. So 1.3 proportional to 65 centimeter, equation number 1. Now these earlier work, I hope you remember. Earlier work, we have proven this, E proportional to L. Right. When another cell of unknown EMF was substituted for E, the balance length was found to be 45. So new EMF balance length is 45. What is the second cell? Right. So you are dividing second equation by the first equation. E1 divided by 1.3 equals 45 divided by 65. From here, you can say 5 times 9, 5 times 13, 13 times 1, 0.1, cross multiply. E1 is equal to 0.9 volt. 0.9 volt means answer number 4. Answer number 4. 10th one, answer number 4. So don't forget this. Huh? Don't forget this. This we have proven. In the 2000 paper also we have done this. Proof done. Proof done. 2000 A-level paper. Refer the earlier 3 videos. Huh? To go to the live, you have it. Count down. Right. Moving on. Moving on. Okay. Radioactive nucleus decays by emission of a alpha particle followed by a gamma particle. The daughter nucleus formed will have a mass number and atomic number. Mass number, atomic number. Look at both carefully. Now, X, A, Z. Alpha particle goes out, 4, 2. Gamma particle goes down. Gamma has no charge, no mass. What is your daughter nuclei? So that is A minus 4, Z minus 2. Z minus 2. A minus 4, Z minus 2. A minus 4, Z minus 2 is answer number 2. A minus 4, Z minus 2, answer number 2. 11th one, answer number 2. Okay, no? 11th one, answer number 2. Right. Moving on. Okay. Consider the following statements made regarding an object of mass m at a height h from the surface of Earth. Gravitational field. So Earth is here. Object is somewhere there at a height h. Radius of the Earth, capital R. Okay, look. Gravitational force does not depend on h. Wrong. If you mark this carefully, the gravitational force on this mass is Fg. Here, mass of Earth. If I write this carefully, gravitational force is capital G, mass of Earth, mass of object divided by R plus H squared. This gravitational force is inversely proportional to R plus H squared. Statement A is wrong. Statement B, gravitational potential energy does not depend on mass, simple m. Gravitational potential energies, gravitational potential there multiplied by the mass kept there. What is the gravitational potential? All of you all know by now. Capital G me divided by R plus H into simple m. Look at the board and tell me now. Gravitational potential energy does not depend on simple m. Wrong? No? Statement B wrong. Statement C. Gravitational potential energy depends on H. Yeah, depends on H. Correct. Only C is correct. Only C is correct. Once you need it, write it down. Question number 12, answer number 3. Question number 12, answer number 3. All right. Write down. Huh? Now, the ones who were there in the theory class, of course, you all know now. These are simple things. But the others, now remember, now I have put the main points. Jot down the main points. Go check your theory notes. Okay, no? Right. Okay. Next one. Two masses, M and 4M, lying on a smooth table are compressed to each other. So you are compressing to each other. Total initial linear momentum equals total final linear momentum. Okay. Initial linear momentum 0. Final linear momentum MVA in that direction. This will jump in that direction. 4MVB, that will jump in the opposite direction. Bring all vectors in the same direction. MVA minus 4MVB. MVA equals 4MVB. VA is equal to 4VB. VA is equal to 4VB. Answer number 3. Answer number 3. Right? Right there. This is connected to law of conservation of linear momentum. Law of conservation of linear momentum. This is connected to law of conservation of linear momentum. Right? Once you need it, quickly write down. By now, I'm sure you've done it. Okay. Right. Moving on. Consider the following statements made regarding the magnification of an image produced by what lens? Convex lens. Convex lens. Right. Now remember, magnification has two forms. One is virtual magnification. One is what? For virtual image. One is for real image. Right. Now, if you take a convex lens, optical center is here, focal is here, 2F is there. Look at this carefully. If I keep an object between the optical center and the focal, if you keep an object here, you will get virtual upright magnified images. So guaranteed H1 is larger than H. From U0 to UF, M increases, correct. Magnification will increase. Magnification will increase. Look at the board now. Next one. U equal F to 2F. Magnification reduces. Right. So what will happen if I keep at F? At F, image at infinity. So image at infinity means virtual, but very big image. Right. Now comes the second one. Look at this carefully. Now, here F, here 2F, here optical center. All of you all know, if I keep at F, image at infinity, if I keep the object at 2F, the image also is formed at 2F. What can you say? Object and image same side means magnification is 1. Magnification has reduced. B also correct. Now they are telling you, see, 2F to infinity, magnification increases. That's why it goes wrong. Now, 2F onwards, if you keep increasing, if the object is at infinity, image will form at the focal point, diminished image. So, U is greater than 2F. Image diminishes. So, there is no increase in magnification. C is wrong. Correct statement is A and B is 2. Right there. When the object is kept between the optical center and the focal, when the object is kept at the optical center and the focal, we will obtain virtual upright magnified images. We will obtain virtual upright magnified images. Next point, right? From F to 2F, when we move the object, from F to 2F, when we move the object, the image will be real inverted. The image will be real inverted. Real inverted, diminished images. Real inverted, diminished images. This is because at 2F, if we place the object at 2F, the image will also form at 2F. The image will also form at 2F, correct? Image will also form at 2F. Next point. As the object moves beyond 2F, as the object moves beyond 2F, the image will be diminished. The image will be diminished. The image will be diminished. Okay. Right. A simple microscope has a convex lens of focal length 5. Has a convex lens of focal length 5. At normal adjustment, what do you mean by normal adjustment? Final image is formed at least distance of distinction. So magnification, normal adjustment is 1 plus d over f. 1 plus d means 25. Focal length means 5. Don't put the sign. Why? You have already proven it using the sign. So your correct answer is answer 6. So answer number 4. Answer number 4. Right. Now, last time also we did a nice question on intensity level. A person hears sound intensity level 10 decibels. 10 decibels. Right. When a speaker produces a sound output of 5 watt, when the sound output increases to 50 watt, the level that the person hears, listen very carefully. What is intensity? Power per unit area. Power per unit area. So assuming the distance is the same, intensity is proportional to power. Intensity I1 proportional to 5 watt. Intensity I2 proportional to 50 watt. From this you can say I2 divided by I1, that is going to be 50 divided by 5. 50 divided by 5 is how much? 10. Right. Now let's work. Beta 1 equals 10 log I1 over IO. What is IO? Reference intensity for the human. What's the reference intensity for the human? 10 to the power minus 12. 10 to the power minus 12. Right. Now, beta is 10 decibels, 10 log. I1 divided by IO. Don't write anything else. Just keep it simple like that. Now they are telling when it's 50 watt, beta 2. 10 log I2 divided by IO. Equation number 2. So what you can do is you can say 2 minus 1. Beta 2 minus 10 is log subtraction. Log subtraction means log division. Take the common terms out. 10 log I2 over IO, I2 minus IO minus log I1 minus IO. Log I1 minus IO. Log I1 minus IO. Log I1 minus IO. Okay. Right. Log subtraction is log division. Beta 2 minus 10. Here if I divide, I2 IO divided by I1 IO is I2 divided by I1. Be careful. Now do the substitution. Beta 2 minus 10. I2 over IO is going to be 10. Log 10 is going to be 1. Beta 2 minus 10, here 10 times 1. From this you have beta 2. Beta 2 is going to be how many decibels? 20 decibels. 20 decibels means answer number 2. 20 decibels means answer number 2. Right. Again, what's the connection? Intensity is proportional to power. This is power per area for the ones who don't know this. So distance to the source is same means intensity is proportional to power. Intensity is proportional to power. You can build the relationship. Okay. Write down the ones who need it. This is important one. Right. Okay, no? Next one. Sound wave intensity 2 microwatt per meter squared. Area is given. Amount of energy passing in 1 hour. Right. Intensity is power per area. Intensity is 2 microwatt per meter squared. Microwatt convert to watt. Power per area. Area is 10 centimeter squared. Convert to meter squared. Cross multiply. Power is equal to 2 10 to the power minus 3 goes there. 10 to the power minus 9. Power is energy divided by time. Energy divided by time. What are they asking? Energy in 1 hour. 1 hour is 3600 seconds. Simplify this 7200. 7200 10 to the power minus 9. If I jump 3 decimal places positive, 7.2 10 to the power minus 6. That is 7.2 microjoules. See whether you have answer 7.2 microjoules. Yes, answer number 1. 7.2 microjoules, answer number 1, 17th one. 17th one. So that is connected to this. Can you see? Anybody at whatever level, from this source, you can learn your theory. And if you jot down the points very carefully, you can do well. Right. Look at the board. Frequencies of the fundamental and first overtone. Frequencies of the fundamental and the first overtone of a stretch string are. Right. Fundamental frequency is what? This is your fundamental frequency. What is your first overtone? First overtone is second harmonic 2 loops. Second harmonic 2 loops. Right. If you want, you can erase this. I'll put in dot lines. Right. Right. This is your F1. This is your F2. What are they asking you? F1 over F2. F1 length is not changing. So 1 over 2L square root T over simple M. What is F2? 2 over 2L square root T over simple M. Right. Now, what are they asking? F1 over F2 divide. Simple. F1 over F2 means 1 over 2L, 1 over 2L cancel off. Your answer is half. Half means 0.5. Answer number 1. Right there. First harmonic is also known as fundamental. First harmonic is also known as fundamental. Second harmonic is also known as the first overtone. First overtone. So by writing equations here, you can easily get your answer. Okay, right. Next question, Doppler effect question. Observer is moving at a speed of sound 40 towards the stationary siren. The source is stationary. Observer is moving towards with a velocity 40. Right. So what is happening? Sound is coming from the source with velocity of sound. Velocity of sound 320 meters per second. I'll mark in red. What is the frequency heard by the observer? So frequency heard by the observer, I'll put as F dash. I'll put as F dash. So what is F dash? Very simple. Look at the board carefully. Look at the board. Look at the board. What's the theory? Velocity of sound with respect to observer. How can you make the observer at rest? Put another 40 in that direction. Velocity of sound with respect to observer. With respect to observer means velocity of sound is 320 in that direction. With respect to observer means make the observer stationary 40 that way. So plus 40 that way, right? Okay. Divided by velocity of sound with respect to source. Source is anyway at rest. 320 multiplied by the actual frequency. Actual frequency 600. So here you will get 360 divided by 320 multiplied by 600. So if you divide this, how will you divide this? 0, 0, 4 times 9, 4 times 8, 8 times 1, 8 times 7, 40 we have 5, 5, 67, 675 hertz. 675 hertz means answer number 2. So by applying Doppler effect, you can quickly get the answer. There. Applying Doppler effect, you can quickly get the answer. Right? So what's the Doppler effect? Velocity of sound with respect to observer. Make the observer stationary that way. Put a 40 that way. 40, 320, 360. Velocity of sound with source. Source only anyway is at rest. Only 320. Into actual frequency. Into actual frequency. So not difficult. I'm sure all of you have got this correct. Right. Moving on. Two bodies having thermal capacities in the ratio 1:4. Thermal capacity means heat capacity. They are allowed to cool. Newton's law of cooling. Then their rate of loss of heat would be in the ratio, right? What do you mean by rate of loss of heat? K times A, theta minus theta R. Right? If their rates of fall of temperature are the same, also you can say Q dot is equal to C delta theta divided by T. So this is the equation from Newton's law of cooling. Newton's law of cooling. Newton's law of cooling. And this equation is from what? Your calorimetry. Calorimetry. Both we are talking about the same thing. Both we are talking about the same thing. Okay, no? There. Both we are talking about the same thing. Right. Okay, give me a second. Okay. Right. Now what? Now what? Both are talking about the same thing. So we can say 1 and 2 are equal. 1 and 2 are equal. So you can say C delta theta divided by T, that is equal to Ka theta minus theta R. Theta minus theta R. They are giving you a very interesting connection. They are telling you if the rate of fall of temperatures are the same, that means this is same. This is same. then their rates of heat loss will be in the ratio, right? Don't be in a hurry. So no need to equate. We can erase this. We can completely erase this. We can completely erase this. Now just look directly. Look directly. What can you say? What can you say? Do I need this? No. Heat capacity is given. This is given. Same. So Q dot is proportional to heat capacity. Q dot 1 divided by Q dot 2, that is equal to C1 divided by C2, heat capacity. Heat capacities are in the ratio 1:4. If heat capacities are in the ratio 1:4, your heat loss, rate of heat loss also will be the same. Rate of heat loss will also be what? Same. Right now. Write the small sentence. We can use the calorimetry relationship. We can use the calorimetry relationship. We can use the calorimetry relationship to find the ratio of the rate of heat transfer. To find the ratio of the rate of heat transfer. Okay. Right. Now quickly mark there from 20 how much you got correct. It's okay. Even if it's 1 or 2, put. Now check and see where you went wrong. The wrong points, I'm sure now you wrote it down. I given you space. No? In that space. Now remember, you take a printout of whatever I sent. Take a printout. In that you all do. Then only at the end you are collecting everything. You have a nice bundle. Everything is there at the very end if you file it properly. Clear? So methodically work, whatever level you are, your discipline and commitment will take you to the next level. That level you will see, it will be a miracle for you. But remember, it's not a miracle. It's your work. You have done the work. Is it clear? Right. Okay then. Moving on. Structured assay. Structured assay. Figure shows a part of the main scale and the vernier scale of a certain vernier caliper when their respective 0 marks coincide. Respective 0 marks coincide. Okay. Right. So 0, 0 coincide. How many vernier scale divisions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if I write here, 20 vernier scale divisions equals how many millimeters on top? 19 millimeters. 19 millimeters. What is the length of a vernier division? One vernier scale division is 19 divided by 20. How much? 0.95. Okay, no? 0.95 millimeters. Okay. 0.95 millimeters. Simple. No? Right. Write it down the ones who need it. Okay. Next. Or otherwise, determine the least count of the instrument. Now, least count of the instrument is, this is your standard equation. Value of one main scale division minus value of one vernier scale division. One main scale division, if I go down a bit, go up a bit, sorry. One main scale division is 1 millimeter. Okay. One main scale division is 1 millimeter. So here, if I write it down carefully, 1 millimeter is here. One vernier scale division 0.95 millimeter. Simplify this, 0.05 millimeter. There you go, the least count. Is there another way to find the least count? Yes, there's a shortcut. Least count is value of one main scale division divided by number of vernier scale divisions. Number of vernier scale divisions. Okay. Number of vernier scale divisions. Okay. No? So least count is equal to value of one vernier main scale division divided by number of vernier scale divisions. From this also you can get your required answer. If you do the substitution, one main scale division is 1 millimeter. Number of scale divisions, there you go, it's going to be how much? 20. 1 divided by 20 is going to be 0.05 millimeters. 0.05 millimeters. Okay, no? Right. Okay. Right. Okay, I'll move forward. According to the above figure, what is the least distance in millimeter of a vernier scale that has to be moved in order to make a vernier mark coincide again with the main scale mark? Right, I'll show it to you. Now you can see there are small gaps here, no? Here, gaps are getting bigger, again coinciding here, no? Right. What's the minimum distance, minimum gap so that they can coincide? The minimum gap so they can coincide back again is equal to what? Least count. Is equal to least count. So if you simplify this, have a look. The minimum distance is equal to least count. That is equal to 0.05 millimeters. 0.05 millimeters. Okay, no? Right. Okay. Moving forward. So they are given you a small cylinder. Nice cylinder is given. A cylindrical metal has a cylindrical hole as shown in the figure. In order to determine the accurate values for the following measurements, which part of the vernier caliper out of external jaws, internal jaws and depth bar would you use? Right. Out of these three instruments, which one you will use to measure H1, H2, D1, D2, right? Okay. So for the measurement of D1, D1 here, internal diameter. Internal diameter means what? Internal jaws. So here you go. Internal jaws. Internal jaws. Okay. Right. Next one. Measurement of H1. H1 is what? Here to here. External jaws. External jaws. External jaws. External jaws. Then what? D2. Where is D2? Sorry. I'm sorry. Yeah? This is D1, no? We'll correct this. D1 is external jaws. D1 is external jaws. Sorry. D1 is external jaws. I thought this was D1. D2, this is D1. D1 is external jaws. H1 is external jaws. Okay. D1 is external jaws. H1 is external jaws. This is D2. D2. I'm getting old. Vision problem. D2. What is D2? D2 is internal jaws. D2 is internal jaws. Okay. D2 is internal jaws. D2 is internal jaws. Right? Internal jaws. Then what else? Measurement of H2. What is H2? What is H2? What is H2? H2 is this depth. H2 is going to be depth bar. H2 is going to be what bar? Depth bar. Okay, no? Depth bar. Depth bar. Okay, no? So here again, let me go back. Let me go back. What is H1? External jaws. What is D1? External jaws. What is D2? Internal jaws. What is H2? Depth bar. Depth bar. Right. Okay now. What are they asking you? Write down an expression for the volume of the metal in terms of D1, H1, D2, H2. So volume of the metal. So what do you mean by this? From a big cylinder, a small cylindrical part has been removed. Here. From a big cylinder, a small cylindrical part has been removed. So the remaining will be the volume of the metal. Right. So if we go up, I hope I can remember the symbols. D1, H1, D2, H2, right? So if you write it, here you go. Volume is equal to pi. D1 divided by 2 is the radius squared H1 minus the smaller cylinder. Pi D2 divided by 2 squared H2. I think this is good enough. No? If you want, you can simplify it further, but no need. Pi D1 squared divided by 4 H1. Pi D2 squared divided by 4 H2. Okay, no? Right. Okay. Once you need it, write it down. Right. Moving on. When D2 was measured, D2 means what? Internal diameter. The position of the Vernier scale obtained relative to the main scale is shown in the figure. So you can see the Vernier scale 0 reading is equal to main scale plus Vernier scale reading. Vernier scale 0 is between 16 and 17. Let's take 16 millimeters. 16 millimeters, 2 decimal place plus. Which Vernier scale division is in line? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see the 14th one slightly to the right, left. 13th one coinciding. 13 into least count. So here you can say 16.00, 13 into 0.05. Your answer is going to be 16.65 millimeters. 16.65 millimeters. Right? 16.65 millimeters. Okay, now. So how do you get the reading? Check where the Vernier scale 0 is. It's between 16 and 17. Use the lower one. Find which Vernier scale division is in line with the main scale. That Vernier scale division multiplied by the least count. Okay, right. Now what? What is the fractional error of D2? Remember, fractional error is error divided by reading. Error divided by reading. Now, error is the least count. Least count, 0.05 divided by 16.65. So you can keep your answer like that. No need simplification. There. No need simplification. So remember this. Error here is actually least count. Error actually here is least count. Don't forget. Error is least count. Error is least count. Okay. Right. Moving on. We are into the essay question as well. Right. So what's the question as shown in the figure? A fun game. A person has to run along the platform and jump. A student of mass 50 kilogram accelerates from rest and leaves the platform with a speed 5 meters per second without any rotation. So if I write here, the student will leave with 5 meters per second. He's starting from this end at rest. Length of the platform is 5 meters, already given. Right. Sorry. I'll erase this. Let me move up. Calculate the acceleration of the student while he is running on the platform. Acceleration can be applied. Supply equations here. V squared equal U squared plus 2AS forward. Final velocity phi squared starting from rest. Acceleration we don't know. Displacement is 5. 25 divided by 10 you will get 2.5 ms minus 2. There you go, acceleration taking place. That's very simple. Huh? Just by applying equations of motion, we can get directly the answer. Okay. Right. How long does it take to reach the other end of the platform? What do you mean by other end of the platform? That means here this time. So we know the acceleration. Since we know the acceleration, we can apply V is equal to U plus AT. 5 here starting from rest. Acceleration 2.5 t. Time is equal to 5 divided by 2.5. 5 divided by 2.5 is going to be 2 seconds. 5 divided by 2.5 is 2 seconds. Okay, no? Right. Right. Next one. State clearly how the student obtained the required external force to achieve this acceleration. So, what's the method? The student is pushing the rod backwards. Front leg is pushing the rod backwards. The rod is pushing the student in the forward direction. So the friction force, friction, normal reaction, resultant actually. Friction force provides the accelerating force. Accelerating force. Right? So the student will push on the ground. When he pushes on the ground, what happens is there will be friction generated. Right? There will be friction generated. Right? This friction generated will cause him to move in the forward direction. I'll just mark the reactions as well. Here you have reactions also. I'll use a different color maybe. Here reactions also are there. Normal reaction, friction forces also are there. Friction force provides the required accelerating force. Clear? Okay. So I think here I can mark it. Friction force, normal reaction. And don't forget, you can mark the weight of the object as well. Weight of the person as well, mg. Okay, no? So normal reaction, friction, weight. Huh? Normal reaction, friction, weight. Right. Moving forward. How long does it take for him to touch water? How long? He has to fall 7.2 meters. Look at the board now. He has to fall 7.2 meters. Look at the board. Initial vertical velocity 0. So when he lands here, however he lands, the vertical displacement will be 7.2 meters. Vertical displacement will be 7.2 meters. Okay, now? So what you can do is apply equations carefully. S equal ut plus half at squared vertically down. 7.2 meters, initial vertical velocity 0, Half acceleration means gravity only is there. Simplify. 14.4 divided by 10 t square. 1.44. T is equal to square root 1.44. What's your answer? 1.2 seconds. In 1.2 seconds, the student will fall down. 1.2 seconds, student will fall down. Right. Okay. Determine the horizontal means according to the range. Range. Huh? So you know the horizontal velocity. Horizontal velocity will never change. Horizontal velocity of this child will never change. That will always be the same. Vertical velocities will change. Even here, horizontal velocities don't change. Vertical velocities will change. That's the difference. Right. Now, if you look at this, carefully, apply equation S equal ut plus half at squared forward. Horizontal velocity is going to be 5. Time taken 1.2. No horizontal acceleration. Horizontal displacement is going to be 6 meters. So range is going to be 6 meters. Okay. Right. Right now, clear now? Range is going to be 6 meters. Right. Now look. Mark clearly the forces acting on the student while he is falling in air. Falling in air. Look, look, look. Falling in air means only weight is acting. You might say, sir, what about air resistance? What about upthrust? No. In our question here, we don't consider those. In our question here, we are not neglecting air resistance. Here. And we always consider point masses. Point masses means upthrust is not considered. Right. Okay, next question. Sketch the velocity graph from the start until he finishes. Right. Mark the axes. What happens? Look at the board carefully. Horizontal velocity. Now you know horizontal velocity will never change. So there is an acceleration from rest until you reach 5. After 5, it's going to be constant. Okay, now. After 5, it's going to be constant. Let's look at the times. Time to fall down 1.2. Time to go forward 2. So here you mark it. Please mark correctly. 2 seconds. Altogether 3.2 seconds. Altogether 3.2 seconds. Now, look at this carefully. Again, look carefully. Yeah? Again, look carefully. Here, 2 seconds and 3.2 seconds. Carefully mark because they will give you marks for the axis. Even here, important. 2 seconds, 3.2. Okay, no? Proportionality, don't worry. Right. Next one. Figure shows the direction of instantaneous velocity when he is at a height 1.25. Calculate the magnitude and the angle between the velocity and the vertical. So he is at a height 1.2. Go back. Let's go back. Let's go back. Main picture. Right. Look at this carefully. Yeah. Let's say he is at a height 1.25 meters from top. 1.25 meters. Look at the board. There will be a horizontal velocity and a vertical velocity. Horizontal velocity and a vertical velocity. Now, what are they asking you here? If you look at this carefully, this is your tangential velocity. Or in other words, what? Resultant velocity. So this is technically your resultant velocity. Yeah? Resultant velocity. I'm marking it here, there, so you understand this. Resultant velocity. Calculate the magnitude and direction of velocity v. Right. Let's go back. So 1.25 meters down. Huh? Right. 1.25 meters down, starting from rest, you must find the velocity. After you find the velocity, problem solved. Here we go. Let's solve it. Here you go. Simplify it. V squared equal U squared plus 2AS vertically down. Vertical velocity V squared starting from rest. Acceleration 10, 1.25. V squared is equal to 12.5 times 2, 25. V is equal to square root 25, 5 meter per second. Look at the board now. Huh? Now you have two velocities. Horizontal velocity is also 5. Vertical velocity is also 5. Now your basic vectors, the resultant will be along the bisector. So how do you find this angle? Angle with the vertical here is theta. So resultant here is bisecting. Resultant velocity Pythagoras apply. Phi squared plus phi squared square root. That is phi root 2 meters per second. Pi root 2 meters per second. What about the angle here? Tan theta is equal to opposite over adjacent phi divided by phi. That's one. Theta is equal to 45 degrees. So velocity is phi root 2 meter per second. Angle is 45 degrees with the vertical. Okay. Now? So you have horizontal velocity 5, vertical velocity 5. Resultant will be the bisector here. Angle is 90. Yeah? But we can't directly put 45. You have to show. So apply Pythagoras theorem, get the resultant velocity. Tan theta opposite over adjacent, you get the angle 45. Okay. This is part A. This is part A. Right. Once you need it, carefully write it down. Once you need it, carefully write it down. Right. Finally, at this instant, the motion of the student can be treated as part of a circular motion around point O. Determine the centripetal acceleration of the student at this moment. Determine the centripetal acceleration of the student at this moment. Interesting. Look carefully. Look at the board, please. Now, what is the acceleration acting vertically? That's gravity. They are telling you we can consider it a circular motion about O. So G cos theta, here you have what? G sin theta. Mass of the object is M, means here you have mg. Who is providing? If you look at the gravity even here, G cos theta, G sin theta. G sin theta is acting to the center. So acceleration acting to the center means what? Centripetal acceleration. Centripetal acceleration. Some of you all won't think that. Here G is acting. Here theta. So G cos G sine. If you want, put the G cos here. Put the G cos here. Sorry. Here you have G. G sine theta. Here G cos theta. G cos theta is what? Tangential acceleration. So G sine theta is acting to the center. So G sine theta is acting to the center means that is your centripetal acceleration. So if I write it here, centripetal acceleration is only G sine theta. So G sine 45 because theta is 45. So G over root 2. 10 divided by root 2 ms minus 2. But I must warn you, do not keep like this. They will marks. So I'll multiply the denominator and the numerator by root 2. 10 divided by 2 is 5. 5 root 2 ms minus 2. Simplified further. Root 2 is 1.414. 27, 3 decimal places. 7.07 ms minus 2. 7.07 ms minus 2. Right. Okay. Moving forward, calculate the radius of the sphere, circle. All of you all know centripetal is also v squared over radius. Centripetal is 5 root 2. V is tangential velocity. Go back. What is your tangential velocity? Tangential velocity is going to be 5 root 2. Tangential velocity is 5 root 2. Go back. Tangential velocity is 5 root 2. 5 root 2 squared divided by radius. 5 root 2. 5 root 2 multiplied by 5 root 2 divided by r. 1 5 root 2 cancel. From this you have your answer. R is equal to 5 root 2. 1.414. 7.07 meters. Radius 7.07 meters. Do not keep in fraction form. People who keep in fraction form, guaranteed no marks. Okay. Right. Okay. Right. So this concludes week number 2, day 1. Week number 2, day 1. Okay. So we have discussed 20 MCQs, one structured, one essay. Tomorrow also we'll meet 20 MCQs, one structured, one essay, and if possible, week day number 4, I have given a paper. Please try the first question. So day 4 paper 1 also we'll do it tomorrow. Okay, now? Right. Okay then. Stay home safe. Keep working. Keep your hope up. Guaranteed. Guaranteed. Trust yourself. You will in the exam. Stay home safe. Good night.